let's talk about Route 53. And before this, let me start by saying that Route 53 is an impressive and reliable domain name system web service offered by Amazon. It's highly scalable and available, which makes it a top choice for businesses of all sizes. By the end of this video, I guarantee that even if you're a beginner, you will have a clear and confident understanding of how Route 53 works. So let's dive right into it. Fascinatingly, Route 53 is named after the port number 53, which is used for DNS traffic. Now, you might be wondering what DNS is and why a service like Route 53 is necessary. So let's start with what is Domain Name System or DNS. A general user of the internet might not realize that when they enter a web URL in the browser, there's a lot happening behind the scenes. But in simpler terms, what's happening is that the domain name is getting mapped to a combination of numbers, also known as IP addresses. This process is necessary for computers to communicate with each other over the internet, and DNS plays a critical role in making it happen seamlessly. And when a user types in a website like google.com, they are essentially making a request to see what's hosted on that particular website or URL. This request is served by a web server, which then checks with the DNS server and asks, where can I find the website for google.com? The DNS server then responds with the IP address where the website is hosted. In simpler terms, this is what happens when you enter a web URL in your browser. However, there's a lot more to this than just this basic process. In a client-server architecture, the client, which is typically us, makes requests to a server to get the details we want. Similarly, when visiting a website like bestbuy.com, we are essentially making a request to access that website. When we make a request to access a website, the DNS server responds to us with the resolved IP address, which allows us to connect to the actual server hosting the website. For example, the resolved IP address for a website could be 192.168.122.22. Note that this is just an example, but I hope you're understanding the point here. And when we say that Route 53 is a domain name system web service, we mean that it provides a highly available and scalable DNS infrastructure that enables developers to manage DNS traffic for their domain names. In other words, Route 53 allows developers to route end users to internet applications by translating domain names like bestbuy.com into IP addresses that computers use to connect to each other. Route 53 is a powerful and scalable DNS service offered by Amazon Web Services, and the DNS that we have here maps domain names like example.com, flipkart.com, pythaholic.com, or bestbuy.com to IP addresses like 192.0.21 or 192.168.64.25. And with Route 53, you can manage and route traffic to resources such as web servers, email servers, and much more. But you need to remember the three things that Route 53 is going to help you with. First is domain registration. Second is DNS routing. Third is health check. Let's move forward with discussing Route 53 and its capabilities in managing DNS infrastructure for domain names on AWS. Websites like Google, Flipkart, Amazon need to be hosted somewhere for users to access them. We know that. And with AWS, we can host a website and provide users with the URL to connect to. This is where Route 53 comes in. It helps manage internet traffic to our domain names, ensuring users are directed to the appropriate resources, and that's how it makes life easier. This is the end user which is connecting to the website, and here we have the DNS resolver. For now, just think of it as a directory where we resolve the queries on behalf of the end user. And with AWS Route 53, we return the IP address of the DNS records that are queried by the DNS resolvers. Resolving DNS queries means converting a user-friendly domain name into a computer-friendly IP address. When a user enters a website domain name in their browser, their device's DNS resolver sends a query to the DNS server to find the IP address associated with that domain name. It also helps check the health of the endpoint for high availability so that we know everything works fine. And Route 53 also provides a user-friendly interface for creating hosted zones, managing traffic policies, and propagating DNS records to its global network of authoritative DNS servers. Don't worry if these terms sound unfamiliar, we'll explore them one by one. And it also helps connect the endpoints or the endpoint instances where the website is actually hosted. And for monitoring and logging and analysis, we make use of CloudWatch by setting alarms and notification mechanisms. And all of this is provided to you by AWS with Route 53. Let's get to the root of it. A DNS resolver is a crucial component in the domain name system. When a user enters a website's domain name in the web browser, the DNS resolver on the device sends a query to a DNS server to look up the IP addresses associated with that domain, or the IP address associated with that domain. This process allows us to connect easily to websites without the need to remember their IP addresses. And DNS resolvers makes the internet more user-friendly, and their importance cannot be overstated, isn't it? Let's suppose we want to make a call. Let's call Susan, our friend. Now we make a request to our voice assistant and ask her to call Susan. What she does is she checks your phone contact database and finds the number and then makes the call. And the voice assistant, I'm sure she doesn't know who Susan is, but it confidently resolves the phone number from the name query and makes the call. This example might seem a little bit of more of a oversimplified version of how DNS works, but it was actually designed based on this concept. Let's suppose you want to tweet. For that, you would want to go to Twitter. So when you type the URL for Twitter, that is www.twitter.com on your browser, the first thing we need to check is where is www.twitter.com. So this is done through a process called DNS, a domain name system lookup. Your browser sends a request to the DNS server to look up the IP address associated with the domain name you entered. In this case, it's twitter.com and the IP address is 157.233.2.0. Once the browser knows the IP address of the website, it establishes TCP connection with the server that hosts the website, and then the server receives the request and processes it. It receives the requested content and sends it back to the browser as an HTTP response. And this is what happens when you try to visit a website. And now let's talk about domain registration. So domain registration is a process of acquiring a unique name that identifies a website on the internet. And here we have the website URL. Let's take this as an example. So we have https://www.google.com/search a query which is equal to example. So this is a basic URL, the example URL, and we'll understand what these different sections actually mean. So the first one is protocol. So a protocol is a set of instructions for two computers to talk to each other, and it provides a set of rules for how data should be formatted, the order in which the message should be sent, and how to handle errors or problems. One commonly used protocol is HTTPS, which stands for Hypertext Transfer Protocol Secure. You already know HTTP, I guess. So there's a secure version of HTTP, that is HTTPS. Second one is domain itself, which is our www.google.com. And if you want yours, you can get it on Route 53, or you can visit Hostinger or GoDaddy.com. Here www is called the subdomain. A subdomain is like a subcategory or subsection of a larger domain, which is google.com. And as you can see, we have a /search here, which is also called as page path. A page path is like an address or location that helps identify a specific page on a website. Think of it like a book in a library, where the main domain name is equivalent to the library, and the page path is like the specific shelf or location within the library where a particular book can be found. This analogy can help you understand how a URL actually works. Next one is the query string. A query string is a way to add extra information to the end of the URL to help the website process request and provide specific information. So let's suppose we are searching for a query, and that query is basically your example. So it will help the website to get that data for you. For example, in this URL, the query string is q equals to example, and it tells the website to perform a search for the term example. I hope you got the point. Now, when it comes to registering a domain name for your own website, there are many domain registrars out there that can help you with the process. Some popular domain registrars are GoDaddy.com, Namecheap, and Bluehost. The process actually typically involves searching for an available domain name, selecting a registration length, and paying a fee to secure the domain name. Once the registration is complete, the domain is yours to use for your website. Keep in mind that domain registration fees are typically recurring, so you will need to renew your registration periodically to keep your domain active. It's not for lifetime. So when you want to register a domain name for your website, you need to go through a domain registrar. So this is a company that manages the registration of domain names and helps you find an available domain name that suits your needs. When searching for an available domain name, you can use a domain registrar's website like Hostinger or GoDaddy. These websites provide a search bar where you can enter the domain name you want and check if it's available or not. Once you find an available domain name that you like, you can actually proceed with the domain registration process. So if the domain name that you want is available, then you can register it by following the instruction on the registrar's website. The registrar has a registry that keeps all the records so that it can inform the registrar that if the domain is available or not. And there is one more important factor here, which is called ICANN. So ICANN is basically your Internet Corporation for Assigned Names and Numbers. It is a non-profit organization that plays a crucial role in managing the Internet's domain name system. And ICANN actually manages the root zones of the DNS, which includes the list of all top-level domains or TLDs, such as .com, .org, and .net. So when I talk about top-level domains, I might say TLDs. So don't get confused. TLD is basically your top-level domain, or imagine .com, .org, .net. So once everything is done, you will need to provide some personal information and payment details and pay for the domain, and then you can make use of the domain that you purchased. Great, isn't it? Now let's talk about DNS routing and what exactly happens when you type in the website name that you wish to browse. Here I'm trying to connect to twitter.com. So a DNS or domain name server is like internet's phone book, which helps you convert the domain name into IP addresses. But you might ask me why it is needed. So when you type a URL into your browser, it goes through a DNS resolver, which acts as a middleman between your computer and the other 3 DNS servers. The first touch point of the resolver is the root name server, which helps find out what top-level domain or TLD the domain uses, like .com, .org, .net. Now here you can see TLD for twitter.com is .com. So once we get that, it passes it on to the .com TLD server. So after that, the .com TLD name server contacts the Twitter authoritative server, which in turn converts the domain name into an IP address. And that's what is sent back to our computer. And we get content to our browser because the browser now understands that twitter.com is 157.233.2.0. And all this happens so fast that you won't notice it until and unless you're using a dial-up modem with a connection of 64 kbps. And that too would be highly impossible. I'm just joking. Now let's talk about domain levels. So everything that we work on starts at the root, that is the dot. The root level domain chain refers to the hierarchy of domain names in the domain name system. So that is basically your dot. Below the root level domain are the top level domains or TLDs. I hope you remember this, such as .com, .org, .net, .edu, .gov, and so on. Below the TLDs are the second level domains, or also called as SLDs, such as google.com or netflix.com, rootserver.net, netnode.se. And finally, there may be third level domains such as www.google.com, or it could be blog.wordpress.com, which are subdomains of the second level domains SLD and represent a specific service or resource on that domain. So now you know that there are levels of domains as well, and they have their own specific use cases. And now let's recap this once again. So root server, when a DNS resolver receives a request for a domain name that it does not have cached locally. It requires a root server to find out which authoritative name server it should contact next to get the information. So as I already told you that it has a .com. So the top level TLD server actually contacts the .com for Twitter, and that is where we go to the TLD. So TLDs are responsible for managing the resolution of domain names for a specific top level domain. So here we have .com. So based on that, it actually sends the request to the authoritative server of Twitter, and then the DNS server actually then resolves the authoritative name server to obtain the IP address for the domain name. And that's how we connect to twitter.com. Let's simplify things even further. Now you want to visit a website that is twitter.com. You hit the URL and your browser talks to the DNS to find out the IP address associated with that. If it has the IP in its cache, translates it and sends it back to you. If not, the name server makes use of something called the NS record or name server record, which is a type of DNS resource that specifies the authoritative name servers for a particular domain. Now you see, we went one step further on reaching to the auth name server or authoritative name server. Here this record contains information about the name servers responsible for answering DNS queries for the domain, including their domain names and IP addresses. So once you get back the information, you send it to the browser again, and that's how it works. So when you want to visit a website, you hit the URL and your browser talks to the DNS to find out the IP address associated with it. If the name server has its IP address in its cache, then fine. Then if it has the IP address in its cache, then it translates it and sends it back to you. If not, the name server makes use of something called the DNS or the NS record or name server record, which is a type of DNS resource record that actually specifies the name servers for the particular domain. Here this information contains information about the name servers responsible for answering DNS queries for the domain that you want, that is twitter.com, including that domain names and IP addresses. And once you get the information back, you send it back to the browser. And that's how you visit the website.
Subscribe to the Pythoholic YouTube channel for awesome content, and it's completely free because we believe the best time to start learning is right now.